Right now, somewhere in China, a 10-story apartment building is being assembled in less time than it takes most people to get through a single working week. Not the foundation, not the frame, the entire structure. Walls, windows, balconies, wiring, plumbing, every fitting. Complete and move-in ready before the next sunrise. 28 hours and 45 minutes. Recorded on camera, verified by CNN, design, and construction engineers around the world. And that was not the peak. That was the opening act. The same company then raised a 57-story skyscraper in 19 days. Then a 26-story residential tower in just over 5. To put that in perspective, a building that height, built the conventional way that most of the world still relies on today, takes 16 months on a fast schedule. 5 days against 16 months. Same era, same planet. Here is the detail that makes all of this genuinely difficult to accept. The man who engineered this approach had no background in construction, no architecture degree, no engineering credentials in that field. For 3 decades, his business was air conditioning. And the reason he walked away from that and into buildings traces back to one morning in May 2008 and an earthquake that took 69,000 lives. Stay with me, because what he built doesn't just change the speed of construction, it changes the fundamental nature of what a building is. If stories like this are what brought you here, subscribe and hit like. This is exactly the kind of thing we dig into on this channel. Zhang Yue was born in Changsha in 1960. His university degree was in fine arts. After graduating, he taught school, then worked as a librarian. There is nothing in that biography that points toward what came next. In 1988, he and his younger brother launched a company called Broad with 30,000 Chinese yuan, approximately $3,000. Their first product was an industrial boiler, built to Zhang's own patent. At a time when Chinese industrial boilers had a dangerous reputation for failure, Broad's held. Word spread, orders followed. In the 1990s, the company pivoted into central air conditioning, specifically a type of chiller that runs on natural gas or waste heat rather than electricity. More efficient, less grid-dependent, dramatically cheaper to operate at scale. Broad began selling to China, then exporting globally. By the 2000s, their systems were installed in buildings for the U.S. Department of Energy, at Qualcomm headquarters in California, and at the Bowery Hotel in New York. Zhang had become one of China's earliest billionaires. He owned a private jet. Then, in the mid-2000s, he grounded it and sold it. He had been watching Changsha's skies darken year by year. The same industrial machine that had made him wealthy was degrading the city where he lived. He began publicly pushing other wealthy executives to do the same. He was not universally popular for it. Then, the earth moved. May 12, 2008. A magnitude 8.0 earthquake struck Sichuan province in southwest China. When the numbers were finally counted, 69,227 people dead, 374,000 injured, 5 million displaced, 6.5 million buildings destroyed. Among the dead were at least 10,000 students, killed inside school buildings that had been constructed during China's rapid development boom. Buildings where corners had been cut, standards ignored, and oversight bypassed. The scandal had a name in China. The buildings were called tofu dreg schoolhouses. And the outrage over those children changed something in Zhang Yue that did not change back. He was based less than 600 kilometers from the epicenter, and he could not stop thinking about one thing. Concrete is rigid. When the ground moves violently enough, rigid things do not bend. They break. And when a building breaks, it does not give its occupants a way out. It gives them no warning. It simply collapses. and everything and everyone inside collapses with it. The material had been failing people for as long as it had been used at scale, yet the entire industry had continued as though no alternative existed. No one had stopped to ask why. Zhang pulled 300 engineers from his manufacturing operation. Not architects, not construction workers, but people trained to build precision systems in controlled environments at industrial speed. He gave them a single directive: rebuild the logic of construction from zero. Not faster concrete, not better concrete. A completely different answer to the question of what a building is and how it comes to exist. That project ran for 7 years before the first real result was ready. In 2009, Broad incorporated a subsidiary called Broad Sustainable Building. And what they built is not construction in any sense most people would recognize. Every component of every building is manufactured inside a factory. Not some components, not the structural elements, every single part. Walls, floor plates, balconies, electrical conduits, already wired. Plumbing runs, already connected. Ventilation systems, already installed. Windows, already fitted in their frames. Interior finishes, already applied. The entire built environment of each unit, fabricated, finished, and inspected under a controlled roof before any of it ever leaves the factory floor. Broad's production facility in Xiangyin, Hunan, covers 230,000 square meters, 32 football fields under a single roof. At peak capacity, 1,800 workers fabricate building modules simultaneously. Each module is engineered to the dimensions of a standard shipping container, 12.19 meters long, 2.44 meters wide, 3 meters high. That precision is deliberate. It means any port, any truck, any freight rail system on the planet can transport them without modification. The walls fold flat for transit. Balconies fold inward. When the module leaves the factory gate, it is a finished room. What happens at the destination site is not construction. It is assembly. There is no wet concrete mixed on site. No curing time, no waiting days between floors while material sets. No weather window required. No parade of subcontractors. Framers on Monday, electricians on Thursday, plumbers the following week. The sequencing that turns conventional construction into a multi-year exercise in scheduling is gone. Because all of that happened simultaneously, in the factory, before the first truck was loaded. When a module arrives on site, it has already been inspected. It has already been measured. It fits because it was engineered to fit, not because someone on site checked it against a drawing and hoped. 3 cranes, a full crew, bolts. That is the site operation. Broad put cameras on a build in Changsha and let the footage speak. The foundation was already set. From the moment the first module was lifted off a flatbed to the moment the final bolt was secured on the top floor, 28 hours and 45 minutes. A complete 10-story residential apartment building. The time-lapse went around the world. Millions of views in days. Engineers watched it silently. Developers watched it twice. Half the industry said the same thing. This changes everything. The other half said, stage demo, controlled conditions, would never work at real scale. Broad did not issue a rebuttal. They built a 57-story skyscraper, Mini Sky City. That is the name they gave it, and the name says everything about where Zhang Yue's ambitions were pointed. 204 meters tall, 800 residential apartments, office capacity for 4,000 workers, 19 atriums inside the building, each 10 meters high, connected by what Broad called sky streets, internal thoroughfares, sports facilities, theaters, gardens. not just a tower, a vertical neighborhood. Assembly time on site, 19 working days. Here is where precision matters, and where honesty about the numbers actually strengthens the story rather than weakening it. The 19 days was not the total duration of the project. It was the on-site assembly window. Before the first crane moved, 4.5 months of factory production had already occurred. 1,800 workers had fabricated 2,736 individual modules in Broad's Zhang Yue facility. At the same time, a separate team had spent 5 months preparing the foundation. By the time assembly began, the entire building existed, in pieces, in a factory. The site operation was repositioning and locking it together. Total project duration, from factory start to finished building, approximately 10 to 11 months. Now consider what 10 to 11 months actually represents. A comparable building, same floor count, same square footage, built conventionally, would take 2 years at minimum, and frequently longer. The parallel factory and foundation model alone compresses the schedule significantly before the assembly speed is even factored in. On site, 1,200 workers held a pace of 3 complete floors per day. Modules came off trucks in a continuous flow. Cranes worked in rotation. Floor crews locked each section into place and moved upward before the shift was done. Over 90% of the structure arrived pre-finished, pre-wired, pre-connected. The people on site were not constructing. They were positioning and fastening. The environmental consequence of the approach was striking as well. Eliminating cast-in-place concrete meant an estimated 15,000 concrete truck deliveries never happened. 15,000 heavy vehicle movements removed from Changsha's roads and air for one building. Mini Sky City shifted the conversation. Before it, modular construction was a credible concept that lacked proof at genuine skyscraper scale. After it, that objection was gone. Developers who had watched from a distance began making calls. City planners started asking questions they had not previously thought to ask. The industry's center of gravity moved. But Zhang Yue had a larger target in mind, something he had been working toward since before Mini Sky City was designed. A project so extreme that not even the Chinese government knew quite what to do with it. And what happened to that project tells you more about the real challenge facing this technology than any of the successes do. In June of 2013, Zhang Yue held a groundbreaking ceremony in Changsha for a project called Sky City. The site was a watermelon field on the city's northern fringe. That is not rhetorical. It was a working farm when the shovels went in. Sky City was not a building in any conventional sense. 838 meters tall, 202 floors. The Burj Khalifa in Dubai, the tallest structure on Earth at the time, stands at 828 meters. Sky City would have exceeded it by 10. Zhang said the assembly could be completed in 90 days, with factory preparation bringing the total to 210. His projected cost was $1.46 billion at roughly $63 per square foot. The Burj Khalifa had cost $450 per square foot. Anthony Wood, executive director of the Council on Tall Buildings and Urban Habitat, said publicly that the engineering community was skeptical about the timeline. But he added something important. If Broad could actually do what it was claiming, the timeline would be the least interesting part of the story. The groundbreaking was a Thursday. By the following Tuesday, Chinese newspapers were reporting that construction had been halted. Broad had begun work without securing all the required government approvals. 3 years of silence followed. Deadlines shifted without announcement. By 2016, the project was officially described in the Chinese press as postponed indefinitely. A journalist who visited the site described what they found. The foundation pit, partially excavated, filled with standing water. Fish had moved in. Local farmers had returned to working the surrounding land. The only evidence that a ceremony had taken place was a cornerstone lying in the grass. Zhang, when pressed on Sky City, said the building would be completed. He offered no date. The technology was not what failed. Every building Broad constructed before and after Sky City was completed as described. The system worked. What failed was the interface between an unprecedented private ambition and a state apparatus that had not developed the tools to evaluate or approve it. A second-tier Chinese city government faced with a proposal to build the world's tallest structure in under a year, using a construction method that did not yet have a regulatory framework? That was not a construction problem. That was a governance problem. And governance problems are slower to solve than engineering ones. That gap, the space between what is technically achievable and what institutional systems will currently permit, is not a footnote to this story. It is the central tension. The question that follows every discussion of construction speed is always the same. If it goes up that fast, how long does it stay up? It is the right question, and Zhang Yue's answer to it was shaped before he built a single module. Remember, he did not begin by asking how to build faster. He began by asking how to build something that would not kill people when the ground moved. Broad's structural material is a proprietary system they call B-Core. 2 stainless steel faceplates, separated by a grid of small-diameter stainless steel tubes bonded between them. The resulting composite panel carries the structural load of the building while being dramatically lighter than the concrete elements it replaces. Broad's own documentation, tested by the China Academy of Building Research using scaled structural models, puts B-Core at 10 times lighter and 100 times stronger than conventional concrete floor plates. Those numbers originate from Broad's technical literature and scaled laboratory testing. Full-scale independent peer-reviewed verification has not been published. The distinction matters, and the story does not require inflation to be extraordinary. What is independently established? Broad structures are certified to withstand a magnitude 9.0 seismic event. The 2011 Tohoku earthquake in Japan, the earthquake that caused the Fukushima nuclear disaster, that generated a tsunami visible from space, measured 9.1. Broad's buildings are engineered to the threshold immediately below the most powerful quake ever instrumentally recorded. The physics behind that claim is straightforward. Concrete handles force through rigidity. When the applied force exceeds the material's tolerance, it fractures. Fracture is irreversible and progressive. Steel handles force through flexibility. Under seismic loading, a bolted steel frame absorbs and redistributes energy rather than concentrating it at failure points. The building moves. It does not crack. It does not collapse. That is the difference between what Zhang Yue watched happen in Sichuan in 2008 and what Broad's system is designed to prevent. Because the structure is bolted together rather than cast in place, it can also be deconstructed. Every module can be unbolted, removed, transported, and either reassembled into a new structure or recycled as raw material. Construction site waste on a Broad project runs at under 10% of the volume generated by conventional methods. No concrete offcuts, no formwork debris, no mixed material landfill. Broad's stated structural lifespan for the Holon series, their current system, is 1,000 years. Conventional reinforced concrete structures are typically designed to a 50 to 100-year service life. The building that was assembled in 28 hours is engineered to stand for 10 times the lifespan of the concrete structures being built beside it. The speed becomes the headline. The structural performance is what sustains the argument. So why is none of this the dominant method of construction in 2026? That question deserves a direct answer rather than optimistic deflection. The global housing shortage currently stands at roughly 100 million units. Construction costs are rising in every major economy. The skilled labor pool is shrinking. In the United States, the average construction worker is over 40 years old, and the pipeline of younger tradespeople entering the industry is insufficient to cover retirements. Cities are adding population faster than housing can be built to accommodate them. Rents climb. Waiting lists stretch years. The technology to address a significant portion of this exists. The proof buildings are standing and occupied. The investment is moving. And yet the default method in most of the world remains poured concrete on-site with the same fundamental workflow that has governed the industry for decades. The reasons are structural, not technical. Building codes in most jurisdictions were written for concrete and timber construction. They were not written for prefabricated modular steel assembly. Revising them requires regulatory testing cycles, code committee reviews, public consultation periods, and political will. These processes move in years, not months. Supply chains are entrenched. The networks of concrete suppliers, formwork companies, on-site subcontractors, and equipment rental operators are not neutral observers of this shift. They are participants with revenue at stake in the existing model. Transition creates disruption for them before it creates opportunity. Developers who have operated profitably within the conventional system for decades are not irrational when they hesitate. The financial risk of a failed modular project in a regulatory environment not built for it lands on them. Their caution is the system responding to its own incentives. And there is a labor dimension that honest accounts do not skip over. The efficiency of modular construction comes partly from requiring fewer people on site. That is a genuine consequence with genuine human impact. The trades that have provided stable employment within conventional construction represent communities and families. Acknowledging that is not a reason to reject the technology. It is a reason to plan the transition rather than pretend it has no cost. Sky City is the parable. The most extreme demonstration of what was technically possible was stopped not by the limits of engineering, but by the limits of the systems surrounding it. A groundbreaking was held. Fish swam in the pit. The cornerstone sat in the grass for years. The gap between what is possible and what is permitted is real, but it is not permanent. In January of 2024, Broad completed a 26-story residential building in 5 days. 100 workers, a crew that boards a single bus. A building taller than most of what lines the skylines of mid-sized cities around the world. Finished and handed over before the week ended. Broad has announced projects in the United Arab Emirates through a partnership with Eagle Hills, the Abu Dhabi Development Group. Projects in the Philippines. Plans for Ohio, Texas, and California. The global modular construction market in 2025 was valued at approximately $95 billion. The projection for 2034 is in excess of $175 billion. Asia Pacific accounts for roughly 45% of that market today, and growth is accelerating. Singapore has mandated modular construction for public housing. The United Kingdom has directed billions toward off-site construction programs. Japan and South Korea are embedding factory-built systems into both residential and commercial development at national scale. The institutional commitment is real and growing across multiple sovereign governments. And yet, the majority of the world's construction workforce reports to sites tomorrow morning to do what they did yesterday and what the generation before them did. The direction is set. The destination is not in question. What remains open is the pace of arrival. A man who built his fortune cooling buildings watched 69,000 people die inside buildings that could not handle one bad morning. He took $3,000, an engineering team drawn from a manufacturing company, and 7 years of rethinking, and produced a building method that is faster, lighter, stronger, more resource efficient, and more durable than the system it is replacing. The buildings stand. They are occupied. The technology has been demonstrated at every scale from 10 stories to 57. The only friction left is institutional, and institutions, eventually, catch up to evidence. Somewhere tonight, in a city whose housing authority met last Tuesday to table a discussion about updating its modular construction code to the next meeting, a family is in the 3rd year of a waiting list for a building that could have been standing before this video ended. What Zhang Yue figured out does not just accelerate construction, it redefines what we are willing to accept from the built environment, and what we are no longer willing to tolerate. If this kind of story is what you came here for, hit subscribe and turn on notifications. We cover exactly this: the moments when one person's question changes an entire industry. And leave this in the comments before you go. A building assembled in 28 hours is engineered to stand for 1,000 years. What does that tell you about every concrete structure you walk past today? We read all of them.